Here's a queue. Here is a queue of queues. All right. I know. Cut me some slack. This didn't really turn out the way I wanted it to. You see, I'm a child of the 80s, and two things that I was really obsessed over when I was growing up was my dirt bike and the arcade. Like many other kids of the 80s, I put every spare quarter I came across into these machines. Dig Dug, Galaga, Dragon's Lair, Russian Attack, they were all great. But there was one that I became particularly obsessed about. It involved this pyramid and this little character, this orange character that had a nose or a snout or a mouth, not really sure. And he would hop along the squares of this pyramid trying to avoid various dangers. And this little guy has even appeared in some recent movies, but unfortunately, he's copyrighted. Now, I thought about maybe using some substitutes, but alas, I just don't think it would be the same. So you got what you got. Okay, enough silliness now. SQS is a highly scalable, hosted messaging queue, and it has available integrations with KMS for encrypting messages, which is really useful if you have to maintain end-to-end encryption. Now, SQS should be thought of as transient storage. By default, the message can stay out there for a maximum of 4 days, but you can configure that up to 14 days. But it's not a long-term storage place. And it also optionally supports first-in, first-out queuing, and we'll talk about this a little bit later. Now, the maximum message size is 256K, but you can scale up to 2 gigabytes by using a special Java SDK. And in essence, that stores the message on S3 and then creates the SQS message as a pointer to that S3 message. Now, a significant benefit of a queuing pattern is the ability to create more loosely coupled architectures. And this permits portions of the interface chain to tolerate downtime or temporary outages without disrupting the whole chain. It also allows us to govern the data flow better. So let's take a look at an architecture. In this case, we have an ERP system that's generating messages, master data updates. The middleware lands these messages into an SQS queue, where they're then picked up by an EC2 worker instance, maybe for some transformation or some augmentation. They're then updated into DynamoDB. Now, suppose the message traffic comes intermittently, maybe 1,000 updates within a few minutes due to a mass change. We could scale horizontally by adding more worker instances and process through that queue faster if we need to. Let's look at a comparison between a standard queue and a first-in, first-out, or FIFO queue. In a standard queue, we have no assurances that the messages will enter or leave the queue based on when they arrived. And for an ongoing process, this could present some risk. The message stream we're receiving is update 1, update 2, update 3, and so forth. And you can see there's various steps to a process. Update 1 is received, update 2 is sent to warehouse, update 3 is picked, and so forth. Now, if we just have a standard queue, we have no guarantee that we're going to be able to process those messages in order. So if we're continually updating the same record, in this case, the final update would be update 3 picked, which is incorrect because we've already shipped this product. We can switch over to a FIFO queue, first in, first out queue, and that will maintain the order in which the messages were received. Now, the big trade-off in this is that enforcing this order processing means that if a message fails or gets stuck, it's going to hold up all the other messages behind it. And this can introduce some latency or delay in clearing queues. Amazon MQ. I wanted to include that in this lesson because sometimes people get confused around use cases between SQS and Amazon MQ. Now, Amazon MQ is just a implementation of Apache's ActiveMQ. And ActiveMQ is a message broker. It takes care of taking in messages, managing them, and letting other applications via API access them. It functions very similar to SQS, but it's a different implementation of a messaging queue. And in the case of Amazon's MQ, it's fully managed for you, so you don't have to install it on any servers, and it's highly available within a region, so you don't have to worry about that either. Now, it fully supports the ActiveMQ API, and it also supports JMS, NMS, and protocols like WebSockets and MQTT for IoT implementations. And it's really designed to be a drop-in replacement. If you currently use a messaging queue on-premise, maybe IBM MQ or something like that, your application should be able to work with Amazon MQ with very little or no modification. Now, when should you use MQ versus SQS? Well, it's recommended that if you're building a new application from scratch, just go ahead and use SQS because it offers a little bit more feature set and it's more tightly integrated into the other Amazon services. And if you already have an application that uses a messaging broker, maybe in your on-prem data center, you can use MQ to really easily kind of lift and shift that to the cloud.